Picture the ultimate tech bro dream, right? You spin up this multi-agent swarm.
Oh yeah, the virtual boardroom.
Exactly. You've got an AI architect, a coder, a reviewer, and they just autonomously debate, code, and deploy these flawless apps while you literally just sit back and watch.
I mean, it looks absolutely incredible on a conference stage. When the demo runs perfectly anyway.
Right, in a demo. But today we are drilling deeply into the details from our sources. We've got this stack of recent developer blogs and enterprise white papers, and we really need to get into it.
Because we're uncovering the harsh reality of why these autonomous swarms fail catastrophically the second they hit real-world production.
Yeah, and we're going to figure out how to architect deterministic systems that actually work. So let's unpack this. It's like a beautifully choreographed dance in a demo, but the second someone steps on a toe in production, it just turns into a chaotic mosh pit.
That mosh pit isn't just random, though. It's a fundamental structural flaw.
Because of the probabilistic nature of large language models interacting, right?
Exactly. The chaos stems entirely from these models trying to interact with each other without hard boundaries. Let's look at what the sources actually call hallucinatory deadlock.
Which sounds intense.
It is. Imagine Agent A passes some data, like a JSON file, to Agent B.
Okay, say Agent A drops a single escaped quote. In traditional software, that triggers an HTTP 422 rejection, a rigid code rule that immediately rejects the bad request. Boom, execution stops.
Right. But an autonomous AI agent, well, it doesn't do that.
It tries to be helpful instead.
Yeah. Agent B attempts to probabilistically guess the fix. It actually hallucinates the missing fields, and then sends a critique back to Agent A.
And then Agent A misinterprets the critique, tries to patch it, and breaks a totally different constraint.
So they get stuck in this infinite loop, arguing over a missing quote.
Wow. So what happens to the system's memory while they bicker?
The context window balloons exponentially. Every round trip reprocesses thousands of accumulated tokens of just, well, meta-commentary.
Here's where it gets really interesting for you listening. Because of something called the lost in the middle phenomenon, the AI actually starts to forget its original instructions due to the sheer bloat of that context.
The instructions drift and the core logic corrupts. And, while they're forgetting their jobs, the meter is running.
And that shatters your SLA, right? Your service level agreement with the user.
Completely. A task that took exactly 4 seconds in a test environment spirals into an 85-second wait. Or it just spins indefinitely until the server throws a 504 gateway timeout.
Which is a financial disaster. I mean, a predictable cost of maybe 5 cents per run explodes into unbounded, non-deterministic loops, burning up to $50 a run.
What's fascinating here is that this exposes a core production law. Enterprise software does not require autonomous deliberation.
It requires predictable execution.
Exactly. Autonomous consensus is an absolute anti-pattern for mission-critical software.
So if giving them the freedom to guess is the problem, I assume we have to take that control away. Code controls the rails, not the AI.
Yes, you replace those emerging conversations with a deterministic state machine.
Stripping the LLMs of their routing power entirely.
Right. They operate only as stateless, isolated compute nodes within explicit boundaries.
Wait, doesn't this completely kill the magic of AI? I mean, it sounds like we are just going back to traditional rigid coding.
You're right to call that out. It is the classic cost of control trade-off. With a swarm, you get high setup speed and unbounded creativity.
It adapts organically to novel inputs.
Right, but by moving to a directed acyclic graph, or DAG,
which is basically a one-way street with no roundabouts, making infinite loops physically impossible.
Yes, you are sacrificing that unbounded creativity for operational safety. You have to. The blueprint for this requires zero-tolerance validation gates.
Like using a validation tool like Pydantic or Zod?
Exactly. The code physically rejects the LLM's output if it's missing a comma. It strips the AI of the ability to guess what went wrong,
forcing a hard stop.
And along with that, you enforce hard lip limits. If an LLM fails a schema extraction twice, you cut it off.
Maximum 2 retries?
Yeah, maximum 2. And then it immediately escalates to a dead letter queue.
Which is essentially just a waiting room where failed tasks sit until a human reviews them.
Exactly.
So what does this all mean for you? It means if you want to build reliable enterprise AI, you have to stop debugging unconstrained agent loops.
You have to use directed acyclic graphs.
Right. Use one-way execution paths and strict validation, and drive those chaotic $50 bills down to a predictable few cents per run.
And if we connect this to the bigger picture, Well, it really makes you wonder about the terminology we use.
Oh, how so?
Well, think about it. If enterprise AI only succeeds when its autonomy is entirely locked in a programmatic cage, are we actually building independent agents or just highly advanced, very expensive calculators?